So this is our propulsion groups. Okay.
I'm there.
Nice to meet you, Andrey.
Good to meet you.
Yes.
My
Yuchi?
name's Yuchi.
Nice to meet you.
Yes. They're our propulsion team. And we're not going to bother Matt because he's very busy. So Mark is modeling our thrusters and working on drawings related to that and improving it. And he has an awesome background in this. He was part of the team that manufactured our El Camino Real, our first mission, within like less than 6 months from contract to launch. So
Wow,
I'm going to
that's
show you
amazing.
more like when
Yeah.
we go in the hallway. But yeah, we
So
have an
here's your,
incredibly
Yeah.
dedicated, amazing team that just makes the impossible happen.
This is like design drawer here.
Yeah, so
Yeah.
this is the propulsion design group,
Yep.
and I'll take you to the other side of the building for our spacecraft. Thank you, Mark. And over here is the replica of El Camino Real. It's the first mission that I was mentioning to you that we're going to be flying in July. What you see here on the X is our propulsion system for it. Basically, it's
that small.
it looks like the size of like a hockey puck. And that little circle you see right there is where the thrust comes out,
Yep.
and then we have the big riser that goes in there. And this is just the structure that holds it. This prop system is, you can see it here inside. This is a 16U demo that we're doing. That's what you see there is right there. The prop tank and the entire feed system. And this is like an image of what the plume looks like coming out of it. And the intent of this mission this year is to basically show that this type of water plasma propulsion system works in space. That, you know, we get data from space on how much thrust it generates, what the efficiencies are, etc., to compare that to the data that we've gathered here.
So basically
on
verify
Earth.
the data that you came up with in your lab.
Exactly.
Very good.
So it's like a verification test. And it flies a lot of the avionics and electronics that we're going to be flying on our next Vigoride missions next year. So this is the first mission we're flying.
I think it's also the first that big of a CubeSat that has been launched ever,
This
right?
is the first 16U CubeSat
Wow.
ever been launched.
They're pushing the limits of the standard.
Yes, we partnered with Digital on this one. They built a lot of the spacecraft structure and avionics and electronics, and they're also one of our vendors for Vigoride and others. So they've been a great partner, and you know we worked with them for building and launching a satellite in like less than 6 months, which was an amazing team. So you will hear more about that launch. It's going to be launched off of a Soyuz in Vostochny on July 5th. This is our prop lab. Charlie?
Hey, Charlie.
Nice to meet you. I guess we're doing some testing for X-band currently. We have a small X-band thruster. This is the chamber that we test in. We have a thrust stand built in. We have an external test stand as well. So currently we're doing some bench testing to build some new prototypes, get them to the point where we have good confidence in them, and then put them in chamber, see how our changes affected the thrust of it, see what changes are beneficial, and eventually we're turning this tank into our endurance chamber. So there's going to be up to 3 thrusters in here, all firing simultaneously. And that gets
that chamber, right?
So that gets us some better idea of the lifetime of these thrusters. So there's a amount of testing that we're conducting here. So
you're running continuously for a big amount of time to stretch.
So 3,000 hours for one of the tests.
Wow.
3,000
hours.
Yep. So
of the continuous.
not completely continuous. They are being cycled.
Yeah.
But yeah, we're looking to get pretty high confidence that these thrusters will do their job for the mission here.
Amazing. Yeah.
So basically, like the mission I was showing you, El Camino Real, the results from that would be compared against some of the results that he gets under vacuum here to kind of check. Kind of, you can imagine like a calibration check.
And it feels like you can also test the bigger versions of your Vigoride here, right? Probably the Vigoride Extended as well.
Right. So what we're going to test in here is just the propulsion system.
Mm-hmm.
We're not going to test the entire Vigoride in this chamber. It's probably not going to fit.
The actual prop module.
Yeah, so this is a subsystem level test setup. When we get to the big system level test where we have the entire Vigoride or Vigoride extended, we have bigger chambers. And you can see these big boxes here. These are what we're setting up now for larger vacuum chambers that will do system level environmental testing. So the environmental testing we'll do is basically dictated by the launch vehicle in addition to our requirements. So you have to test it under vacuum, you have to put it under vibration, sine vibe, acoustic testing, etc. So those will all be done at the next higher level. So this is just subsystem level here.
Very good.
And this is a really awesome chamber that Charlie has set up for us because it's a differential. It has differential ion pumps, which allow it to get down to like 10 to the minus 11 torr.
Wow.
So the spacecraft team is over there. There's Aaron and there's Sam.
Hey guys.
And they're working on developing a Vigoride. We have our PDR, for example, tomorrow or the day after tomorrow. So they're very busy right now.
Yeah,
so
good luck,
we're
guys.
we're not gonna bother this team right now unless you want to talk to them. I'm gonna kind of leave them alone. So our interns, where we're gonna be assembling full spacecraft. So right now you see a high power thruster set up in here and a little vacuum chamber. These are like called little cubes, little vacuum cubes where we put thrusters in and test them. The thrusters in here, so I can't show that to you, but we run the setup here, and this is where we will be assembling our Vigoride and integrating the customer payloads onto Vigoride and doing testing on them here. And because we use water, we can fuel it here. So we will fuel the whole orbit transfer vehicle, Vigoride, here, and then we'll integrate all the satellites, and then we'll package it all up and we'll ship it to launch base. And it's so safe that even with our first vehicle, El Camino Real, we were able to ship it in like a passenger aircraft.
Really?
We just book it economy C. Put
fueled.
the satellite fueled into the chair and just ship it.
So
Just
economy,
fly
right?
it with an engineer.
It flew coach.
Yes, it's flying coach with an engineer.
Wow, amazing.
And that's how amazing. And the biggest problem that they had was actually TSA wanting to go through the security and the fact that it had more than the 2-3 milliliters of water, so they had to swab it.
Swap the satellite.
But yeah, that's the way we're sending it up there. So
amazing.
That's kind of the ConOps. In terms of testing, we'll probably have each of the satellites do our customers' satellites that are going to be flying with us do testing at the satellite level. So they'll do their own TVAC and vibe, etc., to comply with the launch vehicle. Yeah, with the launch vehicle requirements.
Right.
And then we'll integrate it all together, and then we'll ship it.
And then what operations will, if any, will remain at the launch facility?
We don't need them to do anything for us at the launch facility since we fuel here. Usually the operations that are done at the launch facility involve a lot of fueling and hazardous operations. We have no hazardous operations. So we'll be doing everything here. Then we might need to charge a battery or something like that.
But there's no
just
need.
Basically, imagine just plugging it in.
Right.
That's all we really need to do.
But there's no need for the late access to your satellites at the very last moment before the launch to refuel it.
No.
It's amazing.
No, that's what's making it so cost effective. So it's very exciting, and very exciting that we don't need. So you can see this is an office building, and we can build everything here because we're not using any hazardous material. We can use regular plumbing material because it's just water. Right, plastic tubing,
doing plumbing in space since 2019.
We are space plumbers.
So, can you explain what do you do at Momentus? What's your role at Momentus?
So my title is a space systems engineer, but I also, because we all wear a lot of hats around here, I do a lot of the astrodynamics and mission design as well. So I help make sure that all of the parts of the spacecraft are designed properly and interact with each other properly. And then I also do the design of the orbital trajectories that we use to take our customers from one place to another in space.
Can you tell us a few words about how this technology works, the propulsion technology?
Yeah, so the microwave electrothermal thruster, or MET, it's actually a very simple device, and that's what gives it a lot of its advantages. It's basically very similar to heating up water in a microwave, and that combined with the fact that we use water itself mean that the device is very robust but still capable of quite high performance, both in terms of efficiency and thrust, which is really what I think the future of the space economy needs, is some kind of balance between the two of those.
Mm-hmm. Mm-hmm. The way we usually explain it to our customers is it's like a kettle that you put in microwave.
Yes.
Is it
yes.
like right assumption?
that's very accurate, actually. Yeah, because when the steam comes out of the
right.
part of the kettle that makes the whistle, that's basically like our nozzle, right?
Okay. Yeah. Okay. So the kettle in the microwave, right?
Yes.
Okay.
Yeah.
Cool. And what kind of temperatures can you achieve in such an environment?
Temperature is a tricky thing because there's average temperature
yeah.
and there's point instantaneous temperature. The amazing thing about what our device can do is it can achieve very high temperature gradients.
Mm-hmm.
So we can have very, very hot things next to very, very cold things. Mm-hmm. And that's really good because your performance is limited by how hot can you get something, but at the same time your lifetime is limited by how hot are the things, how
right.
hot are the parts of your rocket exposed to.
Will the parts actually withstand this heat?
Exactly, yeah. So we're able to get very, very high temperatures along the axis of our thruster. We're talking thousands of Kelvin, mm-hmm. While simultaneously only having hundreds of degrees in C on the outside of the
mm-hmm.
of the thrust chamber near the walls where you can start melting things. So, mm-hmm. So yeah, that allows us to have really long life, robust thrusters that are not complex to design, or they are tricky to design, but not complex to manufacture at all.
Right. Very good. Perfect.